I'm going to tackle this question here. It says calculate the length of the diagonal PT. This is a wedge shape, which is a bit difficult to see. There's a lot of fuzzy information, so I'm just going to reduce it back to the basics. There it is, there's the wedge, and we're trying to find the line PT. Down here, I've also drawn a 2D version so that we can see what's going on, and we're trying to find that length there. Well, usually this is going to come down to some kind of right angled triangle. So there it is, and I've put in the information P, T and R, and that side there, TR, measures 2.5 centimeters. Okay, all very good. But to find PT, I would really want to know the side PR, because then perhaps I could use Pythagoras. Or I'd want to know one of the non-right angled triangles in the triangle, non-right angles in the triangle, but I don't have those. So I'd like to find PR, because that will help me find PT, but at the moment I don't have enough information. However, PR is also part of another right angled triangle. It's the hypotenuse of triangle PQR. And what information do I have about PQR? Well, all I know at this point is that PQ is 3.8 centimeters. That's still not enough to help me find PR. So what do? I need to see whether QR is part of another triangle. It is. It's part of QRT. It's part of, if you look back at the wedge, it's part of that face there. And I have some information given to me about that. I have that angle RQT is 6 degrees and the RT is 2.5 centimeters. That is enough information to start working out QR. I've got two pieces of information. I can use trigonometry to work out QR. So there it is. There's the 2D version, slightly enlarged, and we're going to go about working out each part step by step. So QR is where we'll start, and for that I've got the adjacent side, that's adjacent to 6 degrees, and opposite. That's going to require the tangent then. So tan 6 degrees equals opposite, which is 2.5, over the adjacent, which I'm going to call x. So x, if I rearrange that, equals 2.5 divided by tan of 6 degrees. Out comes the scientific calculator. So 2.5 divided by tan 6, close brackets, equals 23.8 centimeters to one decimal place. I know I've rounded it. I'm going to keep it on the calculator so that when I do the next step I use the unrounded version. So where do I put that on the diagram? Here. This is now 23.8 centimeters. Okay, well I can use that combined with this length here, so these two, to help me work out PR. I can use Pythagoras to help me work out PR. So PR equals the square root of 3.8 squared plus 23.78 blah 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 squared. Let's do that on the calculator. So I would type in square root 3.8 squared plus answer squared. You see what I did there? I'm using the previous answer, squaring that, equals 24.087 blah 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 blah. So that equals 24.1 centimeters to one decimal place. And that is the base of this triangle, so that's 24.1. Brilliant! I've now got the two pieces of information that I need to help me get PT. So I'm also going to use Pythagoras for that. PT equals square root, the square root of 2.5 squared, so that's this side up here, TR, plus 24.1 squared equals Again, all of this on the calculator. I need to write that a bit higher. So square root of 2.5 squared plus answer squared. I've done it again using the old answer, and I get 24.2 to one decimal place. So 24.2 centimeters, one decimal place. So going back to the original diagram, PT is 24.2 centimeters. And that's the end of the video. Thank you.